All right, so we're moving on to lesson 10.7, and we are going to look at inscribed and circumscribed polygons. So an inscribed polygon looks like this example right here. You can see that the polygon, which is just a closed figure with straight sides, basically, is on the inside of a circle. Each vertex is on the circle, so this is an inscribed polygon. The polygon is inside the circle, so inscribed inside. You can kind of remember it that way. We also have something called a circumscribed polygon. This is where you can see there's a circle that's on the inside of the polygon, hitting each side of the polygon in one spot like that. So each side of your polygon ends up being a tangent segment to the circle. So a circumscribed polygon has a circle on the inside, and an inscribed polygon, the polygon is on the inside. All right, so a couple of theorems to go with that. Actually, they kind of go with the inscribed one. So if a quadrilateral is inscribed in a circle, so if the polygon has four sides, remember quadrilateral means four sides, its opposite angles, ready to write something in, are supplementary. Now, what does supplementary mean again? That's when two angles add up to 180 degrees. So we're saying that the opposite angles will add up to 180 degrees. So for example, in this inscribed polygon, we have angle A, B, C, and D. So according to this theorem, we're saying that angle A plus angle C is going to be equal to 180 degrees. And this is only true if it's an inscribed polygon, so if it's on the inside of a circle. If I drew just a regular quadrilateral, this would not apply. So that circle is important. All right. Also, we would say that angle B plus angle D equals 180 degrees. So they're supplementary. So there's one theorem. All right, the second theorem says if a parallelogram is inscribed in a circle, it must be a rectangle. So I'm going to draw this. It's probably not going to look that great, but let's say here's a circle, and if what's inside the quadrilateral happens to be a parallelogram, that means opposite sides are parallel. So in this quadrilateral up here, you can see the opposite sides are not parallel, but if opposite sides are parallel, then basically what's going to happen is it is going to form a rectangle every time. So if those are parallel and if these are parallel to each other. So if it's a parallelogram, the parallelogram will be a rectangle. All right, those are your two theorems.